Have you ever had that feeling, that creeping unease when an AI makes a decision you
Yeah.
can't quite follow?
Oh, definitely. Like a recommendation that feels totally out of left field.
Exactly. Or you read about some algorithm doing something, well, surprising, maybe even a bit unsettling.
Yeah, those situations where the AI's inner workings are basically a black
Right.
box.
A total mystery. And it begs the question,
Mm.
how do you really trust something you can't fundamentally understand?
That's the core tension, isn't it? We want the power, the efficiency AI gives us.
Mm-hmm.
But we also, deep down, we need clarity. We need some control, or at least understanding. We want to know why.
Absolutely. So in this deep dive, we're really getting into the heart of that tension. We're tackling that infamous black box problem in AI.
And its partner in crime, goal drift.
Exactly. Goal drift. And to explore this, we've pulled together some really fascinating sources. We'll be digging into a pretty groundbreaking patent application. It's for something called the Fractal Identity Map, or FUM.
Right, FEM. And we've also got insights from Theta Driven Coach, a company that's actually pioneering these ideas.
And we'll try to connect these concepts to what leading AI thinkers are saying, people like Wharton professor Ethan Mollick.
Yeah, put it all in context. So our mission here is, well, to cut through that complexity.
Mm-hmm.
We want to pull out the most important nuggets about FEM, how it tries to tackle these opaque AI systems head on.
And look at the implications, right? For business, for ethics, maybe even for future markets, things you might not expect.
Exactly. The goal is to get you better informed pretty quickly and thoroughly on this really critical topic.
Okay, so let's start with a really bold claim we found in the materials. It basically says 100% future profits in the AI era. They're going to come from what's called the gray zone.
Yeah, that's a heck of a statement, isn't it?
It really is.
And what's fascinating is how this gray zone isn't necessarily framed as just a problem to solve and eliminate. No, it's almost positioned as the next frontier for, innovation and profit. It refers to these advanced agentic AI systems. Systems we can't fully explain, maybe can't completely trust in the traditional sense.
And we're going to use them anyway.
That's the assertion. For a competitive advantage, companies will choose to use them. It implies this fundamental shift, moving away from total human control towards managing uncertainty as the key skill.
Wow. That does sound a bit like stepping into a fog, though. So can we define this gray zone a bit more? What does it actually involve?
Sure, it's got a few key characteristics. First, there's opaque causality, meaning the model's behavior just emerges from these super deep networks in ways no human can really simulate in their head or trace step by step.
Okay.
Then there's unverifiable intuition. The AI's output might feel right, it might even be incredibly effective, but there's just no clear explanation for why it landed on that specific decision.
Got it. What else?
Then you've got system drift. This is subtle. It's how the AI's internal states kind of morph, they rewire themselves as new data comes in, as goals shift over time. It's not static.
Right, constantly evolving under the hood.
Exactly. And finally, there's intersubjective misalignment.
That sounds complex.
It just means different people looking at the same AI output or behavior might see totally different things, interpret it differently, which, leads to confusion or arguments.
Okay, I see. But why is this gray zone not just, inevitable, but actually profitable? That seems counterintuitive.
Well, think about competitive markets. Speed, agility, fluidity, they often win, right?
True.
These gray zone systems, precisely because they operate beyond easy human understanding, they can sometimes break through old optimization limits. Find solutions or patterns a more transparent human design system might miss.
Ah, so they can find efficiencies we wouldn't.
Kind of like they cheat the constraints of comprehensibility, as one source put it. And let's be honest, a lot of businesses, maybe even consumers, won't really prioritize full interpretability until something, breaks badly.
That sounds familiar. It sounds a lot like goal drift in our own lives, actually.
And so,
Like you set a clear goal, maybe a business strategy, maybe just getting fit, right? But then weeks or months later, you look at what you're actually doing day to day.
and it's not really aligned anymore with that original plan.
Yeah, exactly, that drift.
That's a great connection. And you can think of the whole AI alignment problem as basically that kind of goal drift, but happening at a planetary scale.
With much, much higher stakes.
Astronomically higher, yeah.
Right.
When an AI's subtle internal shifts could have global effects.
And we're already seeing real-world consequences, aren't we? I mean, Biased hiring algorithms are a classic example.
Absolutely. They perpetuate historical biases just because the data they were trained on was skewed to begin with. These aren't just minor technical glitches.
No, they have real impact on people's lives.
Exactly. And another big issue is the lack of transparency around training data itself.
Right, I saw mentions of that. People like Timnit Gebru pointing out how major labs are becoming less open.
Yeah, she noted they're starting to say that for our own good, they're not going to tell us the data. And Ethan Mollick at Wharton has raised similar flags about, companies not being upfront about unpredictable emergent behaviors or unannounced model updates.
That feels pretty concerning, especially given the scale. We could be talking about AI spitting out nonsensical financial reports.
Leading to terrible investment decisions.
Yeah.
Or chatbots giving wrong answers that just destroy customer trust.
It erodes brand reputation, everything. It really is like that analogy you hear sometimes, trying to fix a car engine when the hood is welded shut.
It's a perfect analogy. You just can't get inside to see what's actually wrong.
So you're just patching things on the outside.
Exactly. And that's why traditional software patches often feel like a losing battle with these opaque AI systems. They're external fixes trying to plaster over an internal, hidden, possibly drifting problem.
So the big takeaway here for you listening,
It's that this isn't just some niche technical problem for AI engineers to worry about. It's fundamental. It's a roadblock to building AI we can actually trust, especially at scale.
and it leaves organizations exposed, right? Financially, reputationally, ethically.
Absolutely. Because you simply can't audit or govern what you can't see or understand.
Okay, that paints a pretty stark picture. Huge risks, a fundamental roadblock. So the critical question then is, how do we pry open that welded shut black box?
Well, this is where the Fractal Identity Map, the FEM, comes in. It's proposed as a radical paradigm shift.
A paradigm shift? How so?
Instead of trying to interpret the black box from the outside, after it's made a decision.
Which is what most explainable AI tries to do, right?
Mostly, yes. FEM changes the game by building the AI's knowledge, its reasoning structure, to be inherently transparent from the inside out.
Okay, inside-out transparency.
Yeah. The core claim is really profound. It's basically a node's structure and position encode its meaning, not just its content. The structure is the explanation.
Wow, okay, unpack that. The structure is the explanation.
Think of it like building an engine where every single part is clearly labeled, not just with a part number, but with its function and exactly how it connects to everything else. The design itself makes its operation obvious.
That's a powerful metaphor. So how does FEM actually achieve this? What are the key principles?
All right, so one core principle is self-legending semantic addresses.
Self-legending.
Yeah. Imagine every piece of info, every concept gets an address. Like, say, science.biology.genetics.CRISPR. That address isn't just some random tag. It intrinsically defines what that element is and where it fits in the bigger picture. It's like having a postal address and a full Dewey Decimal Code combined. You know what it is and where it belongs just from the address itself.
So the location tells you the meaning.
In large part, yes. Then there are weight-ordered hierarchies with short-lex ordering.
That sounds technical. What does it mean practically?
It's not just alphabetical sorting or something simple like that. It's about structurally prioritizing information. It ensures that within any branch of this map, the most important or maybe the most frequently accessed details bubble up first.
So it makes finding relevant stuff easier and more intuitive.
Exactly. Very efficient navigation.
And I think I read it's also multidimensional and self-similar. That word fractal starts to make sense.
Precisely. It means the system uses the same basic organizing pattern again and again, recursively, across different conceptual dimensions or levels of detail. That self-similarity is key to making it scalable and understandable.
Okay, that's interesting. But what about drift? That seemed like a huge problem earlier.
Right. And maybe the most critical part is how FIAM handles dynamic adaptation and drift resistance. The map can learn, it adapts to new data, but a concept's core identity stays anchored to its address. If a concept's meaning genuinely shifts significantly, it gets reclassified. But that reclassification is an explainable, auditable event within the structure.
So it's not like that vague, untraceable embedding drift you mentioned earlier where things just subtly change in the background.
Exactly. Embedding drift in current models means the internal representations of data can shift in ways that are hard to track, leading to unpredictable behavior changes. FIAM aims to make any significant change explicit and traceable within its structure.
That ability to resist untraceable drift, That sounds incredibly valuable.
Hmm.
You also mentioned it constrains the degrees of freedom of a concept. What does that mean?
Yeah, so by locking a concept's primary definition into its structural address, FIME gives every piece of information a stable epistemic weight.
Epistemic weight.
Think of it like its core meaning is more grounded, less ambiguous than just being a point floating in some high-dimensional mathematical space, which is how concepts are often represented in other models. Even as new context gets layered on, the original meaning has a stable home in the structure.
Got it. It provides an anchor.
A conceptual anchor, yes.
Now, the sources, especially the patent stuff, get pretty technical about how this works. What are some of the key innovations mentioned?
Yeah, there are some really novel mechanisms described. One is the E-Centric architecture.
E-Centric?
It introduces this new parameter called E. And the really cool thing is that E simultaneously controls both the system's search complexity, how hard it is to find information, and its explainability cost. And it does this independently of how much data you have.
Wait, so you can add more data without making it harder to search or explain?
That's the claim. It's a potential breakthrough for scalability, allowing you to handle vast amounts of information without losing that ability to explain itself.
That's huge, especially with data growing exponentially. What about finding information quickly?
That comes down to exponential query efficiency. FIME is designed to bypass massive, irrelevant chunks of the data map almost instantly.
Yeah.
Imagine searching a huge library, but you instantly know which entire floors or wings you don't need to bother with. It zeroes in incredibly fast.
Okay, efficient search. What else was revolutionary? There was something about memory addresses.
Ah, yes. The semantic address bus. This is, well, it's pretty out there, conceptually. It's the idea that the actual memory addresses in the computer hardware could carry semantic meaning.
So the wires themselves understand what data they're moving.
Kind of. It would allow the hardware itself to make certain intelligent routing or processing decisions without needing slow software lookups. It could dramatically speed things up and enable totally new kinds of computation.
Wow, that sounds like it could change fundamental computer architecture.
Potentially, yes. It's a very forward-looking concept.
And how does FIME specifically stop that sneaky, untraceable drift we keep coming back to?
That's managed by a threshold-based stability mechanism. Basically, a concept only gets reclassified if its meaning shifts past a predefined significant threshold.
So small fluctuations don't cause constant reshuffling.
Exactly. It prevents that continuous, untraceable drift. Any major change in meaning becomes a discrete, recorded, auditable event within the FEM structure.
Okay. And there was one more core algorithm mentioned, the beating heart.
Right. The consistent weight block rank algorithm. The patent calls it the beating heart. It's this recursive weight-based ranking mechanism that organizes everything, big blocks of information, individual nodes under one single consistent rule.
So it's the underlying logic that makes the whole map work together.
Yeah, it enables that intuitive navigation and allows the map to adapt dynamically while maintaining its structural integrity. It ties all the other pieces together.
Okay, so bringing this all together, how does FEM stack up against other AI approaches we hear about, like trying to explain things after the fact?
Well, FinMAM is positioned as fundamentally different. It's presented as a third category, you could say, interpretable by design.
Not interpreted after the fact.
Correct. That contrasts sharply with post-hoc methods, things like LIME or Esche. Those are clever techniques, but they essentially try to approximate an explanation for a black box's decision after it's already happened. They're looking from the outside in.
Okay. And what about trying to align AI during training, like with RLHF?
That's different too. Methods like reinforcement learning from human feedback aim to steer the AI's behavior during training, but the resulting model is often still a black box. You might get behavior you like more often, but you don't necessarily understand the why any better.
So FENAM isn't just a better explanation tool, it's a different kind of structure altogether.
Yes, and it's also distinct from traditional data structures like tries or knowledge graphs. While those organize data, aims to integrate that multidimensional semantic meaning directly with structured causality. It's not just organizing data points, it's trying to organize meaning itself in a way that reveals causal links.
So what's the upshot? What does this mean practically for you, the listener, or a team using this?
It means, theoretically, that any team or organization using FEM operates within an ecosystem that is designed to explain itself. Alignment with goals, with human values, isn't something you desperately try to bolt on afterwards.
It emerges naturally from the architecture.
That's the idea. It becomes an emergent property, built in from the ground up, accountability becomes inherent, not an add-on.
Okay, let's try to make this more concrete. Can we walk through a real-world example, maybe
Well,
something from business?
Sure, let's take a complex, high-stakes enterprise software deal. These things can drag on for months, right?
Really? Lots of meetings, lots of documents, lots of people involved.
Exactly. Everyone might start out aligned on the core value proposition for the client, but over dozens of meetings, emails, side conversations, things subtly shift.
Yeah, the client's priorities might change slightly. Maybe your team starts focusing on a cool feature instead of the main business problem.
Precisely. That's what our sources call deal drift. And it's a huge reason why promising deals suddenly fall apart near the end. People realize they're not on the same page anymore.
Okay, so how could FEMM help prevent that?
Imagine every key artifact, the meeting notes, the emails, the proposals, the requirement stocks, is automatically given a FEM semantic address.
Like deal.phase2.objections.security.data-residency.
Exactly like that. Now, you have an AI agent built on FEM that constantly monitors the structure of the conversations and documentation flowing into this deal map.
It's looking for shifts in where the focus is.
Yes. If the conversation starts subtly diverging from the core value proposition, maybe suddenly everyone's talking about deal.phase3 features nice to have.integration X instead of deal.phase2.valueprop.core problem Y, the system flags it.
It detects the drift.
It detects a critical structural shift.
Yeah.
And here's the key. The explanation for why it flagged the drift isn't some vague probability score.
It's what?
It's a direct readout of the phonema scripture itself. It can show you the exact semantic path where the conversation started diverging from the agreed-upon core.
Wow. That provides incredible clarity, almost like an early warning system for misalignment.
That's the idea. And it really highlights why just trusting an AI's past performance isn't always enough, especially when the stakes are high.
What do you mean by past performance? Like it worked okay before?
Yeah. There's what you could call an epistemic gap. That's the risk you take when you trust an AI's track record on data it's already seen without truly understanding why it works.
Because it might fail spectacularly when it encounters something new.
Exactly. If it hits a novel situation, a scenario not covered in its training data, and you don't know its underlying reasoning, well, it could lead to catastrophic failure.
Because if your critical AI system can't, in essence, show its work,
You don't really have a reliable partner. You have an unpredictable risk factor.
Right.
M5 aims to bridge that gap because it's built on this inherently transparent structure. The work, the reasoning path, the connections is visible by design.
it gives you that auditable, verifiable map of causality, the why.
And that's also why FIME isn't just about explanation. It naturally doubles as a potential framework for AI governance and risk management.
How so?
Because it provides, theoretically, a concrete audit trail for AI decisions and states. You can see how the system arrived at a certain point. This could be absolutely critical for things like regulatory compliance and to the EU AI Act, for example.
Yeah, those requirements for transparency and auditability are significant.
MFOM could potentially transform those black box risks, which are incredibly hard to regulate, into more manageable, transparent processes.
Okay, connecting this to the even bigger picture, like the existential risks people worry about with AI, there's this analogy used by AI safety advocate Leon Shapira. The doom train.
Yes, the doom train. It's a vivid way to think about it. The idea is that the path towards potentially catastrophic AI outcomes isn't necessarily inevitable. There might be breaks or off-ramps along the way.
Things that could stop it.
Exactly. Factors that could prevent the worst-case scenarios. The source material we looked at outlines 6 key factors, potential breaks.
Okay, what are they?
There's the pace of capability, scaling how fast AI gets powerful. Competitive and geopolitical dynamics, how countries and companies' race affects safety. The philosophical nature of intelligence and value, fundamental questions about what we're building. Then, efficacy of human coordination and governance, can we actually work together to manage this? Economic and resource constraints, practical limits. And finally, unforeseen factors, the unknown unknowns.
6 potential off-ramps.
Yeah.
And each one has a dismissal probability. What's that?
It's basically the chance that the optimistic argument for that break fails. The chance that the doomer counter-argument, the reason why that break won't work, turns out to be correct.
Okay, so if you assume, just for simplicity, that these breaks failing are independent events.
You can multiply their dismissal probabilities together to get an overall probability of all the breaks failing, which would be p-doom in this analogy.
Right, and the example numbers given in the source, 0.85 times 0.65 times 0.95 and so on, multiplying those out gives you about 8.3%.
Roughly. Yes, based on those specific probability estimates in the source.
But that assumes they're independent. Are they really?
Probably not, and the source acknowledges this. For example, intense competition, factor 2, could easily accelerate capability scaling, factor 1, and undermine global coordination, factor 4. They're linked.
Creating feedback loops.
Exactly. Dangerous feedback loops. So when you account for those correlations, those interdependencies...
Probability of all breaks failing goes up.
Right. The source estimates that with moderate dependence, it might rise to around 12%. With high dependence, maybe closer to 18%.
Okay, that's sobering. But what's the relevance of this abstract doom train calculation for, you listening right now, maybe dealing with more immediate business challenges?
Think of it like this. Substitute P doom with, say, probability of our big product launch failing, or probability of facing regulatory noncompliance fines.
Yeah.
The underlying challenge is identical. You're reasoning under uncertainty with multiple, complex, interdependent variables. Things influence each other in ways that are hard to track.
So FEM comes in how?
FEM, by its nature, provides a computable map. It forces assumptions about relationships and weights into the open, into the structure. It transforms that ambiguity into something more auditable, more traceable.
So it helps you model those interdependencies and get a clearer picture of the actual risk profile.
That's the potential. It becomes a tool for clearer strategic thinking, not just about existential AI risk, but about any complex system with interacting parts and uncertain outcomes.
Making the implicit explicit. Now, speaking of clarity and precision, but on a much lighter note, Feeder-driven Coach apparently has this feature called the prank poke.
Haha, yes, the prank poke. It's actually a really clever, playful demonstration of FEM's potential for precise, context-aware action.
How does it work?
So imagine you use it to send a poke to a friend who you know has been procrastinating on something specific.
Okay.
Their phone rings, it's an AI theta coach, and it asks them one single, perfectly timed, contextually relevant question based on what you know they've been avoiding. Like, hey, on a scale of 0 to 9, how much progress have you really made on writing that report today?
Oh, wow. That could be awkward.
Exactly. It's designed to trigger this little sequence. First, confusion. Why isn't AI asking me this? Then realization, oh no, they know. Often followed by an immediate text message to you saying, who did this?
Okay, I can see that.
But it beautifully illustrates FEM's potential ability to understand context deeply and deliver incredibly precise, targeted interventions. It shows the power for things like coaching, nudges, personalized communication, all based on that underlying structured understanding.
That's a fun example, but it does show the power of context.
Okay.
Let's shift gears now to the really big transformative vision presented in the sources.
Yeah.
They draw a parallel between FEM's potential impact and the Black-Scholes revolution in finance.
Yeah, that's a bold comparison, but it's worth unpacking. What did Black-Scholes actually do back in 1973?
It was about pricing options, right?
It was, but the impact was much deeper. Before Black-Scholes, pricing stock options was kind of a dark art, very opaque, based a lot on gut feeling. The Black-Scholes model introduced a common standardized computable language for a key element of risk specifically, volatility.
Okay, a language for volatility.
Right. And this didn't just help people price options more consistently. It fundamentally transformed that nebulous fear of market swings into a fungible, tradable element. Volatility itself became something you could price and trade.
And that unlocked new markets.
Massively. It essentially created the conditions for the modern multi-trillion-dollar derivatives market to explode. It turned opacity into computable risk.
Okay, so the parallel is that FEM could do something similar for AI by creating a language for, what, verifiable competence.
Exactly. That's the core idea. The biggest bottleneck for AI adoption in many high-stakes areas isn't lack of power, it's lack of trust stemming from that opacity we talked about.
Right, the black box problem again.
So LFIM's potential fulcrum, like Black-Scholes volatility, is its ability to create a common, standardized, computable language for verifiable competence.
Making competence measurable and understandable.
Yes. Transforming AI from this high-risk, opaque tool into something more transparent, auditable, and ultimately investable. Giving AI systems a measurable identity whose capabilities and limitations can be understood, tracked, and maybe even priced.
That sounds like it could genuinely unlock totally new kinds of markets, not just making existing ones more efficient.
That's the argument. Think about investment. If you had a standardized FEM audit trail proving an AI's competence in a specific domain,
You could create new financial instruments based on that.
Potentially, yes. Things like AI competence bonds, where the bond's yield is directly linked to the AI meeting certain proven accuracy metrics over time. Or maybe compliance-linked notes that pay out only if an AI demonstrably stays within defined regulatory or ethical boundaries, as verified by its FEM map.
Wow, so you're turning AI performance and compliance into something tradable, like a security.
Exactly, making it more liquid, potentially attracting much larger pools of global capital that are currently wary of the opacity risk. It could also fuel secondary markets.
How so?
If you have a standardized way to map and verify an AI model's competence, you could buy, sell, or license models, or even specific components of models represented in FEM with much greater confidence. You know what you're getting.
Okay, investment, secondary markets. What about insurance? That seems like a massive area where AI risk is a huge headache right now.
Absolutely. And this is where FEM's potential impact could be truly revolutionary, according to the sources, because FEM provides that structural transparency and audit trail.
It enables a different kind of insurance.
Yes, specifically parametric insurance for AI failures.
Parametric.
Parametric insurance pays out automatically based on a pre-agreed trigger or parameter being met, rather than a lengthy claims adjustment process. Think hurricane insurance that pays out if wind speeds hit Category 3 in your area.
Okay.
With them, you could potentially define operational parameters, boundaries of competence within the FEM structure itself. If the AI operates outside those verified parameters, and FEM can demonstrate that deviation.
The insurance policy pays out automatically.
Yeah, that's the concept. This level of clarity and verifiability could be incredibly attractive to the global reinsurance markets. They could potentially package these AI risks into new financial products, maybe AI insurance-linked securities or ILS, similar to how they package catastrophe risk today.
Okay, this idea of insurable competence feels really central then. Can you define that clearly?
Sure. Insurable competence is the ability to actually quantify, verify, and therefore underwrite the reliability of an AI system's stated capabilities.
So turning competence from an abstract idea into something measurable.
Measurable, auditable, and specific enough that an insurer can actually write a policy against its failure under defined conditions. It treats AI competence like a tangible asset or a quantifiable financial risk, reducing that perception of unbounded, unknown risk.
This then leads to another fascinating concept from the sources, the trust option multiple. Why might the guarantee of reliability of the insurance essentially be even more valuable than the AI system itself? That sounds backwards.
It does seem counterintuitive at first glance, but this is the core economic insight, and it connects back to that idea of a risk premium, like an options pricing.
Right.
In finance, an options value isn't just about the underlying asset price, it explodes with volatility or uncertainty. The more uncertain the future, the more valuable the option to protect yourself or profit from that uncertainty becomes.
But what's the volatility in the AI context?
It's the massive, often unquantifiable business and regulatory risk associated with opaque AI. Think about the potential for 9-figure fines under something like the UAI Act if your AI misbehaves in an opaque way.
Or massive customer churn if a chatbot has a major trust-breaking incident, like that 40% figure mentioned.
Exactly. These are huge potential downsides. A FIM-based insurance policy, enabled by that verifiable competence, acts like an option that protects against the severe downside risk. It mitigates what was previously an unquantifiable fear.
So the value comes from mitigating that enormous potential loss.
Precisely. That guarantee, that mitigation of terrifyingly large and unknown risk, can provide economic value that has a huge multiple over the AI's direct positive contribution, like efficiency gains. It's putting a price on the cost of not being able to trust the AI.
So the real engine here, the beating heart of this whole potential market transformation, it's about turning that unquantifiable risk into something quantifiable, priceable, insurable.
You've got it. Evamime's transparent mathematical structure is presented as the key that allows for the explicit pricing of AI risk. And when you can price risk, you can create markets. It creates a potential ecosystem where trust itself has a demonstrable price and value, driving new forms of capital investment and innovation.
So wrapping the segment up, what's the single most important takeaway for you?
I think it's that ephemerum or approaches like it aren't just about making AI explainable for, academic curiosity or basic compliance.
It's about something bigger.
It's about making AI insurable. And by doing that, laying the groundwork, potentially, for a whole new generation of financial and insurance products specifically designed for the unique opportunities and risks of the AI era. It's about fundamentally changing AI from an opaque liability into a more measurable, manageable asset class.
Wow. What an incredible journey we've taken in this deep dive.
Yeah.
We started in that murky gray zone of opaque AI, grappled with Goldwift.
Then we explored FIM's really unique structural approach, transparency, and auditability from the inside out.
Right. We saw how it could work in practice, preventing deal drift, even using that doom train analogy to think about managing complex, interconnected risks.
And the prank poke. Can't forget that.
Definitely not. And then we looked at this truly transformative vision, the potential to create insurable competence and revolutionize markets, drawing parallels with Black-Scholes.
It's a lot to take in, but we really hope this deep dive has given you a valuable shortcut, a way to understand a critical frontier in AI development.
Equipping you with insights into how these incredibly powerful systems could potentially be made more trustworthy.
And maybe giving you a glimpse of where future value and, frankly, future challenges will emerge. It's
Yeah.
about getting beyond the daily headlines to grasp some of the fundamental shifts that might be underway. Hopefully you had a bit of an aha moment there.
I mean, it may be a final thought to leave you with, something from the sources that really resonated. AI is rapidly becoming fundamental infrastructure for our society, isn't it?
Yeah, the comparison to nuclear stewardship in terms of global importance feels apt sometimes.
So if we accept that old idea, we shape our tools, and then our tools shape us, it really forces the question.
What kind of structure should this foundational AI be built on for the future we want?
A provocative thought indeed.